Hello again, everyone. This is Bob Martin, the RC Subguy with the NautilusDrydocks.com, and I am exceptionally excited to announce the release of our latest 3D CAD file package for you 3D printing aficionados out there. One of my favorite modern boats of all time, the Russian Typhoon. Let's take a look. All right, what we are looking at here is the finished prototype of a 3D printed hull in 1/144 scale. So it's about 4 feet long. It's just over a 6-inch beam to it. So it will accept a number of watertight modules to make it go. This was printed at a little bit rougher resolution just because I wanted to streamline the printing process to get this done as quickly as possible for you guys, and yet it still turned out really darned cool. Some of the features of these files when you get them, you've got the option of simply mounting the dive planes, the forward dive planes in a fixed position, or if you get fancy, the files are also included for fully retracting and functional bow planes, so that's pretty exciting. Another great feature, if you're open for it, 2 versions of this section of the hull. One is closed missile hatches and the other one has separate missile hatches, so you can actually rig these up to open and close, and you get missiles with it as well. Great detail here. These files were created in conjunction with a very talented modeler out of Canada by the name of Randy. He provided the main hull files, and then I went again and modified them, tweaked them for optimal RC use. But this is the setup, and I'm going to be carrying scale brass scimitar props for this boat that you'll be able to purchase on my site to go in hand with your printed boat. All right, everyone, let's get started with this Typhoon project. And I like to start at the stern of the boat, working on the linkages there. So the parts that we are going to need to worry about are the stern section, which is hull section 2 and hull section 1. And these mate together really, really cool. They basically snap together just like that. You'll just have a little bit of filling and sanding to do in between from a cosmetic perspective, but we're not there yet. So what we're going to want to do is grab our rudder support pieces and clean everything up. We want to clean up the seams, remove any flash or brims or skirts that we've got on those particular parts, and we're going to get some hardware to create linkages in the stern. All right, this is what I have done. I have opened up the holes for the shafts to 1/4 of an inch, just using a standard drill bit. And now these are the pieces that you're going to need to make it functional. These are 1/8 inch inside diameter oil light bushings, and I sell these at NautilusDrydocks.com. And what we're going to want to do is basically press fit these into place inside these holes, so that the outside edge on the inside of this shrouded area sticks out like a 1/16 of an inch or so. So I'm just going to go ahead and get that done, and I'll show you what the result looks like. Okay, here are the installed bushings. You can see those in place now. I've actually installed them so that they're flush with the back, and they protrude about 1/8 of an inch into the inside there, which is certainly not a big deal at all. I think it will work out really well. I'm going to start worrying about this upper rudder. Now, I haven't cleaned this up. I'm going to do that now with some sandpaper and such to make sure that it fits really well. And this is going to get installed on hull section 2, just like that. Now you can see this orientation. There's pins. There's one right there, and that is actually the shaft for the rudder. That's going to go all the way through into the lower. So it's actually supported top and bottom. What I'm going to want to do here, I'm actually going to drill this out, and I'm going to put a brass bushing in place so that that 1/8 inch drive shaft slips nice and easily in there. All right, I want to show you what I'm going to be talking about every time I make up a linkage shaft or a control shaft, okay? 1/8 inch rod, 5/32 tubing, all right? And this just is going to slip in there, and it's going to be a bushing that's going to allow absolutely unrestricted movement of that control surface. So if we take a look at what that's going to look like, this, for example, is going to go up through and in here, and then this bushing is going to fit up inside that sleeve on the bottom there, so that this spins absolutely freely with no binding. So I'm not going to go into this with every control surface that I install. I'm going to assume you just watched this part, okay? So when I install the bushing and install the shaft, this is what I am talking about, all right? All right, gentle persuasion time. I did not drill out the hole for the actual upper rudder, okay? What I'm going to do is I've just pushed this in, and now I'm going to make sure that the bottom is aligned. I'm going to tap this. Until it comes all the way out the other side. And now that is completely in place, and it moves nice and freely inside the arm. And now all I need to do is slip that bushing over the top to make a perfectly frictionless fit. All right, here we are. This is the finished control surface. This is the upper rudder. As you can see on the bottom there, we've got that sleeve, that bushing in place. And I've put just a little bit of thin CA in there to lock it, but this is nice and free moving and ready for installation into the bow or stern section, hull number 2. And you can see that's just going to go just like that, and that's going to move back and forth just like that. And I'm going to put a sleeve in the bottom there, and then that is actually going to fit into the rudder support on the lower end. All right, I moved on to the lower rudder. You can see that right here, and this is not in place. I've got the shaft press fit into the lower rudder, and I've got those bushings on the inside there, leaving room for the linkage horn that we are going to install there momentarily. But again, the big thing, make sure you've got good alignment and that you've got pure, unrestricted movement of that lower rudder. Here is the completed lower rudder assembly. I'll turn that the right way so you can get a better idea what that looks like. Just used a sort of off-the-shelf linkage horn in there, but I do sell linkage horns on my website. If you wanted them, you'd look after the 1/8 inch linkage horns. And yeah, just got the linkage connecting rod right here running straight forward, and we're going to slip that through the hull like this. And once that is all connected together, then still got control of our linkage. All right, before we go further, before we glue hull section 1 and 2 together, we need to install our dive planes, and they go right here. And I'm going to cheat on that a little bit. You can see that we've got some holes right here, and that passes all the way through. But I'm going to make life really easy for myself, and I'm going to drill from the outside of this stabilizer all the way through, so there's a hole that goes through the entire thing. I'm going to make that a little bigger than 1/8 of an inch, actually 5/32 of an inch, so we can fit those brass bushings in. All right, here is a little trick for getting these rods through here without having to pound on it. I'm just going to take my drill and I'm going to attach it to this 1/8" brass rod here, and I'm going to hold on to the dive plane, and I'm just going to spin that rod so it goes all the way through. So that's gone all the way through that dive plane. I'm just going to keep it going all the way into the next side. You can see that popped out over there, and then we're going to do the same thing with the other dive plane. All right, here is my completed stern section. We've got the lower rudder, as we showed you earlier, and we've now got our dive planes here. And what that required, and I don't know if you're going to be able to see this at all. I'm going to get that in there. See if I can take a picture. But it goes right on that inside, and you need to make a very, very short arm on the control horn there. So because there's a limited amount of room, so probably only like 1/4 of an inch, but it works out really well. We got really good throw on here. I think it's going to work out really good. Now we're going to attach the hull section 1, which is completed, to hull section 2, which is completed, and in theory the stern will be all set to go. All right, we've got our hull, rear hull assembled, and we've got our rudders, and you can see they're both kind of moving in the same direction, but we want them linked together. And to that end, what I have created is using a couple of wheel collars, plated wheel collars. This is 3/32 of an inch. Even though I used 1/16 rod, it just gives it a little bit of slop, a little bit of play, make it easier to put on there. And all I'm going to do is just going to slip it over both of those rods, just like that. And what that has now done is effectively, once I tighten them down, linked both rods together. I've just got to tighten it up, and it allows me some adjustability in both, so I can move it back and forth and get everything perfectly aligned. All right, now we are going to start assembling the hull sections. I've got the lower section of hull 3, so this would be 3B in your parts numbers. And if you take a look, there's a groove in hull 2 and a tab in hull 3, and those, if you've printed things nicely, are going to mate up and make a really strong joint. So we're going to start assembling all of the lower hull sections together, making sure that we've got really good alignment. And I'm going to be using some cyanoacrylate glue that is rubber reinforced for strength, and basically glue this all together and start making a boat. All right, things are coming along nicely. I've got hull section 4 glued to 3, and I just want you to note that this notched section is the remnants of the bayonet system that was the original intent of the boat, but I changed it to make it better access to the interior. So I'm going to talk about the joint between hull section 4 and 5, and for that you need the lower bulkhead piece that looks something like this, and you'll see that that fits perfectly right here. And it creates a lip of about 3/16 of an inch. And glue that in place, and then you can glue hull section 5 in place. Make sure for all of these joints you're roughing up any mating surfaces with a coarse grit sandpaper. That is just going to infinitely increase the binding ability of your adhesives. All right, let's talk about these missile doors on the top of the hull. Now these are just right off of the printer. I just kind of cleaned up the edges and sanded the edge. The important part about this is that you want to clean up around the perimeter of all of these openings. And there is a little lip that's on the inside there. What you need to do is use your knife and cut it so that it's flush. So remove that lip. And when you do that, I'm going to try and do this without dropping this in the hull, you end up with this perfect flush fit for the torpedo doors. And you need to do that for all of them, and it's likely, or maybe unlikely, I don't know, my printer did not catch this for whatever reason. So I'm going to need to put these parts in place and then do a little bit of filling in there to get everything perfect. But for this step, clean up the perimeter, get all of the doors fitting perfectly flush, and then we'll take a look at the internal mechanism. Okay, next step, I've threaded the appropriate sides onto an 1/8 inch brass rod, and it's friction fit, so they can move when you give them a little wiggle. I've also spaced them so that they are correctly spaced to fit in the holes. Now we're going to wiggle that and push them through, leaving the brass rod on the inside. All right, I am going to go into how to create a little linkage horn. And this is the way that I do this really often. This is just some liquid flux. You can use normal flux too. This is a 1/8 plated wheel collar and some 1/4 inch thin brass. And what I'm going to do here now, I'm just going to add just a little bit of solder, silver solder, to the top here, just enough to get a little layer, and the same here. And that done, we're just going to hold that right on the top, heat it up, and let it cool. So now, the only thing left to do is to drill out that 1/8 inch hole again and add some 1/16 inch holes for a linkage to connect to. And I'm just going to set this on the drill press here. I got it set up with an 1/8 inch bit. So I got this gripped firmly, and we're just going to blast that hole back through the middle. So we've got our hole in there, and then if we shift off to the side here, all I'm going to do is just clean off these rough, sharp edges. Let's run this back through just to clean up any burrs. Give it a little wiggle. Now we need to swap this out for a 1/16 inch bit. And we're just going to drill a couple of holes for a linkage to go through, so that we've got some adjustability. And once those are through, I'm going to just run this back, and we're going to just open them up a little bit. Just give it a little wiggle. Very good. Now we can snip the linkage free. The horn free. Maybe clean that up a little bit there, and now we've got a little linkage horn. So in practical application, this spacing is exactly what we need. The width of a wheel collar gives you the correct spacing for the missiles, the missile doors, and then this can slip over the end just like that. And now we've got a little arm that we can move back and forth that's going to open and close our missile doors. So what I'm going to do, I'm going to rough up these wheel collars. I'm going to glue them down in place, and I'm going to tighten that down, and then we'll see if it works. Okay, here is the completed linkage. You can see that they are all in place, seated. I've got my arm tightened down. I got these glued. Again, very important to rough up the wheel collar so that you get a really good bite when you glue those. And this is how they actuate here. So we'll have that arm is basically going to be in charge of swinging those pieces open and closed. Now, if we take a look at the top here, we run into, or we now see some of the design constraints that we ran into. When this swivels out and down, these little nubs, these little arms, impact the hull because of the angle that they're coming down on. And so I notched these. In hindsight, you know what I probably might have done is just cut them right off. But that's completely up to you. It's got a little notch right now, so it's kind of a little, you know, interesting detail in the hull. And the other thing is they're only going to open approximately 90 degrees, which is actually good from a linkage perspective, but the reason is that this top part is rounded. As it folds back, it impacts the hull as well. So this is what we got. I will also say that it took me a little bit of tweaking for these openings to make sure that everything sat perfectly flush in there, but it seems to be working really well right now. Let's get the other side put in. Okay, missile hatches have been completed on this prototype. Here's the inner workings there. Those just open and close, and here are the missile hatches on the top side. So pretty cool. Kind of stoked to get them all rigged up and working. All right, it may look like we did a huge jump here, but really we didn't. All I've done is put a little bit of filler on the seams of the boat, primed it and sanded it again, and this is probably the most labor-intensive part of these builds with 3D printed parts, because you're trying to get rid of these striations that are an inherent part of the 3D printing process. And so basically the procedure for that is filler for major gaps, a high build primer, so a filler primer, sand, prime, repeat as needed until you're happy with the finish. So basically at this point I'm going to continue with this until I'm satisfied with that, and then we're going to go on to the hold down part of the boat so that the upper hull stays bolted to the bottom, and we'll also get into the bow retracts. All right, as you can see, I have based the boat out in a flat black paint, and I've used this Liquitex acrylic spray paint in carbon black. Got this off of Amazon. It's not super cheap. I think it's like $14 a can, but man, it works good, and you really don't need to worry about overspray, which is really nice. And it comes in various colors. So this would be the lower hull color. The other thing I wanted to touch on was a really cool way of doing waterline markings. You can see I've got them started over here. I've got my drawing here to show where to put them, and all I've done is I've used some tape, marked out the appropriate spacing in pencil. You probably can't see it there. And I'm going to use this little paint pen with a fine tip. This is a Uni Posca in white, and got that off of Amazon as well. And really, again, just because of time, I'm going to kind of eyeball the width, but you would certainly be able to put another strip of tape there to have your width worked out. Now let me get zoomed in here a little bit so you can see what this would look like doing the application. So all I'm going to do, you can see that this starts out with a small mark, and then a large mark. peel the tape away, and you've got your waterline markings. Works really good for quick and dirty waterline markings. I really like the way it works out, and it saves having to make dry transfers. Okay, it is time to work on some bow planes, and these are the main components. We've got the bow plane itself, we have got the mounting bracket, we've got the swivel arm, we've got bushing, and this is something that you're going to have to source. This is a like a ball and socket connector for linkages. You can get these online almost anywhere. Let's see if you can focus on that. There you go. But basically it's got a little ball that goes into a nylon socket there, and that is going to allow us to have our tilting actuation for our bow planes. So what we're going to need to do, I just got my drill here, I've got a 1/8 inch drill bit, and we're just going to drill out these holes just to make sure that the parts are going to slip through easily without binding. So do that for all of these openings. They're all 1/8 of an inch. Now the other thing that you're going to need is 1/8 inch brass rod, and what I'm going to do to start out, I'm actually going to put this in my drill. And I did not drill out my bow plane, you'll notice that, because I actually want a really tight friction fit. I'm going to put this in here, and I'm just going to spin it into place until it seats at the bottom. So now this is a nice tight friction fit for the forward dive plane. It won't require any glue, it won't require a set screw or anything like that. You're going to make sure, obviously, with all of these parts that you're prepping them, sanding them smooth and everything before installation. The interior pieces you don't have to, because that's not a cosmetic part. But the bow plane you're going to want to sand a little bit to get those striations and ridges off of it. All right, I've cleaned this up, and the bow plane moves nice and easily inside there. You need to be able to insert it and remove it very easily. Otherwise, you're going to get some binding in that part there. Now, this sleeve, so what you're going to need to do now is take that collar, that retaining collar, and you can see that there are holes that were printed in there. And if you need to, you can bore that out, but what you need to do is take your little ball socket there, and that's going to screw into the hole, and it will actually, when it's fully seated, lock that rod in place. So what we're going to want to do is just put that in, drill that out if you need to, and screw in that ball socket partially. So there we go. I'm just going to screw this in right there, and I'm going to make sure that when screwed down all the way, that it is protruding into that center bore. Now you'll notice, if for whatever reason, if your ball socket there is too short to go all the way through, there's a second hole that I included in the files, and you can drill that out for a set screw, and then you can retain the rod in that manner. This goes in between these two arms, just like this, okay? And then we're going to insert the dive plane into that. And again, you can bore that out, make sure that it slips in, but you don't need to make it so that it slips in. You just need to be able to push it in for a nice friction fit. So I'm going to work at that. So I've determined that the length that needs to be between this point and this point needs to be 19 millimeters. So we're going to mark out 19 millimeters, and we're going to push this rod through until it is at exactly 19 millimeters. and then we can lock it down with our socket. All right, I've got my assembly in place there right now. It moves nice and freely, 19 millimeter spacing in between here. Now we can tighten down that ball socket to make sure that it doesn't slip on the collar. And to do that, I'm just going to use my handy dandy needle nose pliers, give it a twist until that seats without stripping my plasticky threads in there. So now we are all set to go. We can trim off any excess in there, although having it out doesn't really do anything except potentially impact clipping onto our little servo arm there. All right, I'm going to take a little bit more of this brass tube, or brass rod, sorry, and I have not drilled out the bottom hole of here. I am going to, again, friction fit that in until it goes all the way through and it's not impeding that. And then what we can do, if we back that out, you can put just a drop of thin CA in place there at the base, and that will lock it down. All right, I've trimmed that down a little bit, and now we're going to retain that with a plated wheel collar. That's just going to slip over the edge there, take our little Allen wrench, and tighten it down. And again, not so tight that it affects it. This needs to be able to swivel nice and easily. So we can see now, if you're looking at this from the top, how this is going to work. The assembly swivels in, it swivels out, and then you can adjust the pitch of the bow planes using the ball socket there. Now for the next part, you're going to take a threaded coupler, and that's going to go on that nylon retainer. Now screw that on about halfway so that you've got a little bit of adjustability, although we'll have other areas to do that. And then this simply snaps on the top, and we've got our actuating bow planes. All right, next step, we need to get something in here to actuate the bow retract. So got another piece of 16th inch brass rod, and what I'm going to use is this handy dandy bender thing. You don't need one, but man, it sure makes life easy to make the Z-bends. See how easy that was? It's a miracle. So what we're going to do is drill out this little hole on the outside here for a 1/16 inch hole, and this is going to get threaded through it, and that is what is going to actuate the retract. There we go. It's in the hole, and it's ready to extend and retract that bow mechanism just like that. Now we got to put this thing in the hull. All right, here is the starboard side bow retract mechanism in place, and I want everybody to realize this is the top hull and it is upside down. All right, so this is the starboard side bow retract mechanism secured in place. Now, for reference for you for installation, the trailing edge of that bracket is exactly 34 millimeters from the edge of the forward bow section. So from that seam, 34 millimeters right in there. And then from a height perspective, you want the bow plane obviously to be kind of centered in that slot. And looking at it from here, because this is horizontal, you want it to be, right about here, where it'll end up working out. Regardless, you just want to make sure that when it retracts, it is perfectly level and that it slips through. So you might want to just put a tack in the corner, attack in the corner, actuate it, make sure that it's not binding, that it's not hitting, and you'll be in good shape. And if you want my measurement, my critical measurement there, it's 11 millimeters from that bottom edge to the bottom edge. Bottom edge of the slot to the bottom edge of the bracket, 11 millimeters by 34 millimeters. All right, let's take a look at the completed bow retract linkage assembly. And this is the way that I set it up, but you certainly don't need to follow my lead there. All I did was create some connecting bulkheads out of 1/4 inch thick plastic. And I got some stainless steel set screws in there so you can adjust each one of those individually. And basically the way that this works is this top one extends and retracts the bow planes. And then the bottom one controls the movement of the bow planes. Very simple. This bulkhead, this bracket that I fabricated, keeps everything aligned and makes sure that everything operates smoothly. So certainly something that you could replicate, but lots of different ways to go about it. All right, I got a little bit of a bonus for you guys that buy the files. Now you'll remember that I created those actuating missile hatches on the top of the upper hull, and we can take a look at them here. I went into getting those all set up and functioning, and they open and close. And you know, it's kind of terrible because there's really nothing underneath. So what I went ahead and did is created some missiles for you guys. This is all part of the package, and if you go ahead and situate these directly underneath the missile hatches, you've got the missile launch tubes and removable missiles. This is a pretty decent scale replica of the actual Russian intercontinental ballistic missiles that they had on the Typhoon. And yeah, you can do all sorts of cool things. You know, situate them in a semi-launch position, resting position, or if you are of a suitable technical capability, hey, you know, print these out in a good solid material, pressurize them, and have them launch. That would be terribly exciting. And here is just a quick look at the hold down system that I put in here. Basically, this is just a piece of 1/4 inch plastic that extends about up to here, all the way down. So it's a good solid bond. And if we pull that back, you can see that hole now lines up there. And then what I've got is this stainless steel thumb screw. And this just simply gets put into place, torqued down, and because it does protrude, you can just use your fingers to open and close it. If you don't like the way that it sticks up, if you're you know, a stickler for the details, replace that with a flat-headed screw, stainless steel screw, and you'll have a nice flush fit on the back. Well, there you go, everyone. This is the build-up and overview of the 1/144 scale Russian Typhoon model submarine. I really hope you enjoyed it. If you did, we got lots of other options for you as well on the website. We've got a number of boats, including the 571 Nautilus, Los Angeles class submarine. Skipjack is going to be coming out soon, and we've got many more available. So go ahead, check it out. You can purchase these files on the website at nautilusdrydocks.com. And I really hope you enjoy it. I would love to see your finished project. So if you do purchase them, send me a picture. I'd love to see what you do with it. Again, my name is Bob Martin, the RC Subguy with the nautilusdrydocks.com. Thanks for joining me, everyone. We'll catch you next time.